Hello guys. So today I will be making a mathematics video of something called the Moivre's theorem. Ugh. So basically the Moivre's theorem has this one formula in it where we need to find the complex root of a number in the complex plane, and to do this we will use a formula I'm about to show you. Okay, so the formula is the nth root of r modulus r times cosine of theta plus 2 pi k divided by n plus I. So here we just add on the imaginary part. I times sine of theta plus 2 pi k divided by n. So this is the formula to do this problem. To basically find the nth root of r, we need to do this formula. So first we need to define a couple of things. Let's actually switch to a practice problem. Let's say this is a common exam question I'm about to show you. You've got a practice problem number 1. Switch colors here, which is z4 minus 128 z is equal to 0. And they're asking us to find the complex roots of this equation. So basically, first off, we need to isolate this guy right here. So we need to find our variables. We can't have the z attached. So we need to factor this. Z cubed, and this is just a general rule of mathematics, z minus 128. So this is the first root is going to be 0, okay? Because the first root of this number here is going to be 0, our first value for our Moivre, our first root, we're going to put z1, right, is equal to 0, okay? Now, we're going to rearrange this. So we're going to solve for z. We're going to ignore this, and we're going to solve for z, right? Let's just copy this, and it'll be all right. It's simple. So all you need to really remember when you see this problem right here, something like this, z to the power 4 minus a number equals 0, is if it's got a negative sign, it's going to become a positive. If it's got a positive sign, it's going to be a negative. Let me show you. So we got z is equal to 128, right? So this is what we're going to use in our Moivre's theorem. So we moved over him to over here. So we got z is equal to 128. Okay. Now we need to define a couple of other things. So let's define our modulus. Our modulus r is equal to the square root of a squared plus b squared I. So the imaginary part, a squared, b squared, right? But as you can see over here, we don't have an imaginary part. We only have a real part, which is 128. So our modulus becomes r is equal to the square root of 128 squared plus 0 squared. Okay, so we can get rid of this. And now, obviously, 128 squared, the square root of that is going to be 128. So our r is equal to 128. And because we factored out this exponent, and we got cubed here, our n in our formula, the n root of r times the cosine of theta plus 2 pi k, that's going to be 3, not 4. So we're going to start off with, actually, yeah, 3 square root of 3 128 times the cosine of theta plus 2 pi times 0, because this is the first one we're doing, is 0, okay, divided by 3, our n, plus I times the sin of theta plus 2 pi times 0 divided by 3. Now you might be asking yourself, what is theta? Well, this is where things get a little bit interesting. Let me extend this first, hold on. Black. Okay. So I want you to remember a formula. So basically we have our imaginary part, right? A and BI. So we got the real part and our imaginary part BI, right? Here we don't have an imaginary part. We only have A, which is 128, right? Our imaginary part. Because we don't have it, we don't just magically ignore it. We say, excluding the I, we say B is equal to 0, okay? We need to have two conditions for our theta, okay? So basically, we use this formula. The cosine of theta is equal to A divided by our modulus R, which, oh yeah, the modulus R is 128 also. Okay? So this guy becomes 128 divided by 128, which becomes 1. So cosine theta must equal 1. Now, to find sine, it's very similar. We take the imaginary part, which in this case is b, which in this case is 0. We divide it by the modulus r, which in our case is 128. So our theta for sine is equal to 0 divided by 128, aka 0, right? So now you think, oh, okay, I'm going to plug these two numbers into the Moore's theorem. But no, that's not what you're going to do. You have to find what degrees satisfies this condition. Who whose sine am I going to take to get 0, and whose cosine am I going to take to get 1? All right, so bear with me. Let's stick to the unit circle. At the bottom we have 270. Here we have 0, which is also the same thing as 360. Okay? On the far left, we have 180. And on the top, we have 90. So where on here are we going to get sine of 0? So the vertical part is going to be 0, and the horizontal part is going to be 1. Well, 180, the cosine of 180 is going to give us -1. The sine, the sine of 180 is going to give us 0, right? So probably it's going to be 0, aka 360, which is going to satisfy the condition. As in these two quadrants here, cosine is always positive, and in these two quadrants here, cosine is negative. Okay? So we're going to take the positive quadrant's cosine, which is 0 or 360. So our theta is going to equal 360. So theta is equal to 360. And since one unit circle is, half of it is pi, right? Which is 180. 2 pi's is going to give us 360. So our theta is equal to 360 degrees, and or we can say 2 pi. So let's go back to our formula, okay? Make sure to save this or screenshot it if you need it. I'm going to delete it because I'm running out of room. Not green. Okay. So we've determined that our theta is going to be equal to 2 pi, okay? So we just easily replace theta with 2 pi. So the third root of 128 times the cosine of 2 pi plus 2 pi times 0, which is just 0, right? Divided by 3. And we're going to get plus I sin of 2 pi plus 2 pi divided by 0 divided by 3, okay? So what's this going to give us? We're going to get rid of this one right here. And that's going to leave us with the third root of 128 times the cosine of 2 pi divided by 3. Okay? Plus the same thing on this side, plus I sin of 2 pi divided by 3. So, now you may be asking what the hell is going on. I don't know my radians. I only know degrees. Right? So sometimes it does help to simplify it, okay? So to turn this into degrees, right, without a calculator, as in calculus tests, the calculator is not allowed. We get 2 pi over 3. We multiply this guy by 180, divided by pi, which simplifies to 180 divided by 3, which again simplifies to 60 degrees. So our theta is gonna be 60 degrees. Make life a little easier. I'm gonna show you guys a trick, okay? Third root of 128 times the cosine of 60 degrees plus I times the sine of 60 degrees. Okay? So, you're on the test, you're stuck, you don't know how to draw the unit circle. What are you going to do? Well, there is a trick which I want you guys to know for finding the cosine and sine, okay? So right now, I want you to get out your left hand, palm faced forwards, like this, okay? All fingers included. And for each finger, I want you to label it by degrees. 0, 30, okay? 45, 60, and 90. All right. So our theta that we found is 60, okay? So I want you, so basically, when we take the cosine or sine on our hands, for our cosine, we're counting how many fingers we have above 60. And for our sine, we are counting how many fingers we have below 60. So the formula is the square root of number of fingers, right, divided by 2. So for 60, for the cosine of 60, we have one finger above 60, which is 90, right? So the number of fingers is 1 cosine divided by 2. Well, a lot of people stop here. Actually, you're not supposed, because the square root of 1 is, well, 1. So the cosine of 60 is equal to the square root of 1, which is 1, divided by 2. Okay? Now, moving on, we're going to do sine for 60. How many fingers do we have below 60? We got 1, 2, and 3 fingers, all right? So our sine is going to be the square root of 3. Well, you can't really do that in your head. Divided by 2. And that's fine, okay? So sine of 60 is equal to the square root of 3 divided by 2. Okay? So basically now we found the cosine of 60 and we found the sine of 60. Okay? We've, in the previous step here, found the first one, which when you have to factor this, when you have this one, you have a z here and a z here, and you've got this power, you're going to subtract 1 from your n, and that you're just going to say is 0, okay? So z1 is equal to 0, okay? Now we're going to see what z2 equals to, all right? So z2 will be equal to the cube root, the cube root of 128 times, what was our cosine? It was 1/2. Okay? Plus the square root. Oh. plus the cube root, of 128. And what was our sign? It was the square root of 3 divided by 2, okay? Square root of 3 divided by 2, okay? So on your answer sheet, when they ask you for the complex roots of this expression, your z2 is going to be this, and remember, our z1 is going to be 0. Now we've got one more, right? Which is z3. And I want you to notice something. This number right here is equal to the power after we factored, which is cubed, okay? So, this time, things change a little, right? So I want you to notice here, this number, 0. This is our first one that we've done. However, right, when we do the next one, this number is not going to be 0, it's going to be 1. Okay? So now we're going to do z cubed, which is the cube root of 128, right, times the cosine of theta, which is 2 pi, because we're working with 360 degrees, okay, plus 2 pi times 1, okay, divided by 3. We're going to also do the sign for this. I times the sine of 2 pi plus 2 pi times 1. I just like to include it because then you guys see exactly what's happening. Okay? Divided by 3. So now we're going to simplify this right here. It's going to be the cosine of 4 pi divided by 3, the cube root of 128 times the cosine of 4 pi divided by 3, plus I sine of 4 pi divided by 3, okay? So we're going to have to we're going to have to do some math, okay? So what I like to do to simplify, to dumb this down, there's a real easy way. So what did we say pi was? Pi was 180 degrees because 2 of the pi's is 360, right? Well, we got 4 of them. So we could even say this is 720 degrees divided by 3. And yes, you can divide it by 3, okay? So we get 3 going into 720. Okay, that's 2 times 3, 6, 1. Bring down my 2, 4. The answer is 240. I'm going to check that on my calculator. I cannot make a mistake when I'm teaching. 1 second, guys. 720 divided by 3. Yeah, 240. And now this is an excellent example because this is going to get a little bit weird, okay? The cosine of 240 plus I times the sine of 240. Okay? And we're going to all multiply this by, of course, the third root of 128. Obviously, that's not something we're going to calculate here, but you can do it on the calculator. But they should take it on the test the way it is. if you just put it like that. So you might notice that basically, well, I cannot do this on my fingers. So what am I supposed to do? Well, I want you to remember these 4 points on the unit circle. That's it, okay? We've got 90. We've got 0, which is the same as 360. We've got 180. And then down here, we've got 270. And what was our degrees? It was 240, which is going to lie somewhere right here, okay? So very important. When you are taking the cosine or sine of these angles, you want to measure the distance in degrees or radians, depends on you, from this number, right, to the x-axis, right? So if we had some number here, we would measure the distance to the x-axis, right? You don't want to find the difference between 240, 270, which is 30 degrees, and you put it on your hands, you're going to get flipped answers. You're going to want to see what's the distance from 240 to 180, right? Which is 60 degrees. Now we will get the right answers. So remember the finger method. You have your thumb, your pointing finger, your ring finger, middle finger, and pinky. 0, 30, 45, 60, 90. Okay? Cosine up and sine is down. What did we say our distance was from the x-axis? 60 degrees. Okay? So we go one up. Okay? Your cosine is going to be 1 finger is above 60. The square root of 1 finger is above 60, which is 1, divided by 2, which is 1/2, right? And then we're going to have our sine of 60, which is 3 fingers underneath the square root of 3 divided by 2. However, I want you to pay attention to something. Earlier, I said something about it being positive and negative based on where it is in the unit circle, right? So remember, here in this quadrant, cosine is positive, sine is positive. Here, cosine is still positive, but sine is now negative. Okay? And over here on this side, both of them are negative. Cosine is negative, and sine is also negative. It's just like a number line, guys. Think about it that way. And then this here, cosine is negative, so the vertical component, the horizontal component, is negative because it's going to the left. And our sine is positive. So where does 240 lie? It lies in the quadrant where our sine and cosine is negative. So this guy and this guy is going to become negative. All right. Also, this is equal to cosine equal to negative 1/2. And sine is equal to negative square root of 3 divided by 2. So now our final answer, Z3, is equal to the cube root of 128 times the negative 1/2. Guys, I'm sorry, I'm tired. I'm trying to focus here. Plus, and always include the I, okay? Always include the I. I might have not included the I up there, but you always want to include the I. Plus the third root of 128 times the negative square root of 3 divided by 2. I. Always include the I. Okay? Otherwise, it's not going to be right. So this is our final answers, right? Is this one, Z2, Z1, okay, and Z3. Now on the exam, you want to, of course, write them just on top of each other. So let me show you what I mean. Like this. Oh yeah, look at this. I made a mistake, guys. What mistake did I make? Didn't put my eye. Always gotta put your eye. So yeah, this is how you do the Moore's theorem. I hope I could share valuable information. Uh, and I wish you guys the best of luck on your Calculus 1 exams. And have a good day. Thanks for watching.